Number 2, standard vapor compression system produces 20 tons of refrigeration using R12 as a refrigerant while operating between a condenser temperature of 41.6 degrees Celsius and an evaporator temperature of negative 55 degrees Celsius. Now determine the refrigerating effect in kilojoules per kilogram, then the circulating rate in kilograms per second, the power supplied, the COP, the heat rejected in kilowatts, and finally the volume flow rate in liter per second. So now we will write the given. We have the temperature of the evaporator, which is negative 25 degrees Celsius, and the mass is 20 tons. The condenser temperature is 41.6 degrees Celsius. I'm using the R12. So from the table we are going to identify its value. So we have the enthalpy 1 is equals to 422 kilojoules per kilogram. Then we first write the TS diagram. Here the temperature is located. We have now negative 25, then 41.6. Now to solve the refrigerant effect, so we have H1 minus H4, then direct substitution. We got now 100.256 kilojoules per kilogram. For letter B, we are going to find the circulating rate in kilograms per second. So we have the 20 tons or 70.314 kilowatts. So we convert it. So mass flow rate times the refrigerant effect, or the RC, or the refrigerating sa condenser. We have 70.34. So we have our mass flow rate 0.702 kilograms per second. So it is the mass circulating rate rather. So for letter C, we are going to find the power supplied. Now work, or the power supplied, is equals to mass times H2 minus H1. Then substitute the given values. We have 0.702 multiplied by the enthalpy H2 minus H1. So we have the power supplied is equals to 25.07 kilowatts. For letter D, we are going to solve for the COP, so refrigerating effect over the work. So direct substitution, we have 70.34 over 25.7. Then for our QR, or the heat rejected, we have mass H2 minus H3. Then direct substitution, we have the heat rejected is equals to 96.08 kilowatts. For our final problem, the volume flow rate in liter per second. So we have the volume flow rate is equals to the mass circulating rate times the volume, which is 131.283. So solve it. So we have 92.16 liter per second. That's for number 2.